So when you think about what makes a car safe, what comes to mind? You're probably thinking airbags, right? Seatbelts, crumple zones, all the usual stuff. But today, we're going to look at a piece of engineering you see every single day but probably never, ever think of as a life-saving device. Let's get into it.
Okay, so let me just ask you, what do you think it is? It's not the brakes, it's not the tires, not even the anti-lock system. It's something that's, hiding in plain sight. And here's the twist. Its main safety job isn't even about protecting the driver.
It's the hood. Yep, the hood of your car. This big piece of metal, or as we're about to find out, maybe not metal at all, is an absolutely critical piece of safety gear for pedestrians. This drawing shows you its basic shape, but believe me, its real job goes way beyond just keeping rain off the engine.
See, in modern car design, protecting people outside the car has become a huge deal. And yet, the tough part is, in a collision with a pedestrian, it's incredibly likely that their head is going to hit the hood. So the big question for engineers is, how in the world do you design a hood that can absorb that kind of impact and reduce a potentially devastating head injury?
Okay, so the first piece of this puzzle is all about the material. The stuff a hood is actually made of plays a massive role in how it handles the energy from a crash. It's not just about being strong, it's about being smart.
On one hand, you've got your traditional steel. Sure, it's tough, it's durable, but it can be really rigid. And that's a problem, because it can transfer way too much of that impact force. But on the other hand, you've got advanced composites. These things can be engineered to have this perfect mix of strength, lightweight, and, this is the key part, the ability to soak up energy in a really controlled way. And that leads us to the hero material in this study, KNAF fiber. Now, this isn't some crazy high-tech material cooked up in a lab. It's actually a natural fiber from a plant, kind of like jute. But what's amazing about it is its incredible strength, both against impacts and when you pull on it. It's a sustainable choice that's also a real powerhouse.
And get this is where it gets really interesting. Just look at how KNAF stacks up against some other well-known materials. For tensile strength, that's basically how much you can stretch it before it snaps. It actually beats carbon fiber in this study. And for compressive strength, how much you can crush it, it's nearly 3 times stronger. So this isn't just some eco-friendly option. It's a legit high-performance material.
But a fancy material is only half the story. The real secret to a super safe hood is also found in its shape. Specifically, we're talking about the geometry of that inner support panel. This is where the engineering magic really happens. The researchers looked at a few different designs. First up was this conical structure. The idea here is pretty cool. These little cone shapes are meant to act like tiny shock absorbers. In a crash, they're designed to buckle in a controlled way to just soak up and spread out all that force. Next, they tried a more traditional grid pattern. You've probably seen something just like this if you've ever popped the hood of your car. It gives nice, even support across the whole panel. It's a solid, classic design, right? But is it the best one? And that brings us to design number 3, a web of triangles. Now, there's a reason engineers and architects are obsessed with triangles. They are just an incredibly strong and stable shape. The thinking here was that this kind of structure would create a super stiff and really resilient inner panel.
So, we've got our amazing KNAF composite material, and we've got 3 different designs for the inside. So, how do you test them? Well, thankfully, you don't have to build and smash dozens of real cars anymore. Nope. Welcome to the world of virtual crash testing.
The technique they use is called finite element analysis, or FEA for short. The simple way to think about it is this. A computer takes a 3D model of our car hood and just shatters it into thousands, sometimes millions of tiny little virtual pieces. This mesh lets the computer figure out how every single tiny piece reacts to force. Then it puts all that data back together to give an unbelievably accurate prediction of what would happen in the real world.
And this is what that looks like in practice. This here is a digital twin of that conical hood design, all covered in that digital mesh. Every single point where those lines cross, that's a calculation the computer's running. It's like having a million tiny physicists all reporting back at once on how the hood is bending and stretching during a simulated crash. It's incredible.
And this is exactly the kind of cool stuff you get from these simulations. On the left, you see a stress test. In these images, blue is what you want. Blue is good. It means very low stress on the material. And on the right, we're looking at how much the hood actually bends. Again, a whole lot of blue means this structure is holding its shape like a rock star.
All right, we've seen the material, we've seen the designs, and we've seen the super high-tech way they test them. Now it's time for the big reveal.
Let's look at the data and see which design actually came out on top.
So, what's it gonna be? The shock-absorbing cones, the classic rectangular grid, or that super rigid web of triangles? The numbers don't lie.
And whoa, just look at these numbers. The conical and rectangular designs, they saw over 20 megapascals of stress and bent by more than 20 millimeters. But the triangular design, it is not even in the same ballpark. Just 1 megapascal of stress, and it deformed by less than a single millimeter. I mean, that difference is just staggering.
So yeah, it was an absolute knockout victory for the triangular structure. It was just so much stiffer and bent so much less than anything else. When you combine that amazing Knauf composite with this incredibly rigid internal shape, you get one seriously tough hood.
And they didn't even stop there. They also ran what's called a modal analysis, which is basically a fancy way of testing how the hood vibrates. You don't want a hood that starts fluttering around at highway speeds. And guess what? Once again, the triangular design proved to be exceptionally stable. So it's not just strong, it's also stable under real-world driving conditions.
So what's the big takeaway from all this? Well, this kind of research is really about a fundamental shift in how we think about car safety. It's about expanding that circle of protection beyond just the people inside the car to include everyone out there on the road.
So let's just recap what we've learned here. First, smart, sustainable materials like Knauf fiber are the real deal. Second, when it comes to a hood, the secret to its strength is really on the inside. Third, in this particular showdown, triangles were the undisputed champions. And finally, and most importantly, this is all part of a bigger mission to engineer cars that are safer for everybody.
And hey, don't just take my word for it. The researchers themselves put it perfectly, and I think this really sums it all up. It's not just about numbers on a screen. It's about making changes that decrease injury to human body during accidents. At the end of the day, that is the only thing that matters.
We started this whole explainer just by taking an ordinary object, a car hood, and looking at it through a new lens of safety. It really makes you wonder, right? What other everyday things that we just take for granted could be totally reimagined to make our world just a little bit safer for all of us?